Hello, everyone, and welcome back to Met Zone African Motives. We are still looking into grade 11 physical sciences, and we are looking into the topic forces and Newton's laws. We have already covered much ground. Now we are about to conclude where we want to dive deep into Newton's law of universal gravitation. We want to see what is it that Newton's law states. What was the main idea behind, say, Newton's law, and how does it apply in our everyday lives, and how can we use it to calculate maybe one's object's mass, or else the radius, the distance in between, the relationship, draw graphs. We need to understand that so that in our daily lives as well as in our examinations, whenever we are asked about Newton's law of universal gravitation, we are able to apply it. We are able to actually investigate what it foretells. So without wasting time, let's look into the definition that I brought to you here. We are saying that each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and is inversely proportional to the square of the distance between their centers. So what it simply means is that, say, Newton's law of universal gravitation foretells us that whenever there are two bodies in the universe, just know that each body attracts every other body with a force that is directly proportional to the product of their what? Of their masses. Mean to say that, let's say you've got one body here, body A, and another body here, body B. It simply means that each body, either body A or body B, attracts the other body with a force. The force of attraction that is in between these two bodies is directly proportional to the product of the two masses of these objects, which is to say product of mass 1 times mass 2. However, though, it is inversely proportional to the distance in between the two centers of these bodies. That is what the universal gravitational law tells us. That wheresoever you are, you attract the next person with a force that we term the force of gravity, or the force of gravitation, that is having a magnitude that is directly proportional to the two masses of you and the next body, and inversely proportional to the distance that is in between you two guys. So this tells us that the greater the magnitude of the product of the two masses, the greater the force of attraction in between those two bodies. And then the greater the distance, mean to say the longer the distance in between the two centers, the smaller the force of attraction. That is what Newton's gravitation law tells us. So I brought you guys the two graphs so that you can actually get to see and be able to interpret graphs. So the first graph is that of force against the product of the two masses. So we are saying that this force is the force of attraction that would exist in between two bodies, where we would say that this is the force that each body attracts the next body with. So this force will increase as the product between the two masses of the bodies increases. So the relationship between the product of the two masses and the force of attraction is directly proportional. So you would find a straight line graph between the force of attraction and the product of the two masses. But however, though, the force of attraction is inversely proportional to the square of the distance in between the two sensors. Mean to say that the longer the distance, the smaller the force of attraction. So I've got a diagram that can help us picture what we are saying. We have got, let's say, body A and body B, where body A has got mass 1 and body B has got mass 2. So you would see that body A and body B attracts each other with a certain force, where we are saying that F1 is equal to F2. These are the force of attraction, where we are simply saying that the universal gravitational force is equivalent in between body A and body B. And that force is directly proportional to the product of mass 1 times mass 2. But however, it will be inversely proportional to the square of this distance that is in between the two centers. And we can use this to formulate a law that says F is equal to G, where G is the universal gravitational constant, times M1 times M2 over R squared. So, in summary, this is what Newton's gravitational law foretells us. So, how do we apply it in our daily life? How do we apply it to solve questions? How do we apply it to determine different scenarios? Let's look at this example question that I took from a past exam question. So you would see that we're given two different planets. We've got planet Earth and planet X. And they are saying a planet X has been discovered to have the exact same mass of Earth. The distance between the centers of the two planets is 4.2 times 10 to the power 26 meters and is represented by R. So this is the distance between the two centers. The center of the planet Earth and the center of the planet X, that has been discovered to have the same mass as mass of the Earth. So we are saying mass of Earth is equal to mass of planet X. And the distance in between these two, which is the distance in between the two centers, is equal to 4.2 times 10 to the power 26 meters. Given that, they are now saying state Newton's law of universal gravitation. So I will not waste any more time, but I will just get to take you back. We say that each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. That is what Newton's law of universal gravitation foretells us. So if they say state Newton's law of universal gravitation, that is what you simply state. Now they are saying, calculate the magnitude of the gravitational force that the Earth exerts on planet X. So you would see that F is equal to G M1 times M2 all over R squared, where M1 is the mass of planet Earth and M2 is the mass of planet X, where we have been told that M1 is equals to M2. So it's more like we are saying F is equals to G M1 times M2 all over R squared. Therefore, this would go to say F is equal to G M1 squared all over R squared. Now, what we now need to find is what is the mass of the planet Earth. We now need to find what is the mass of the planet Earth. Mass of the planet Earth. So usually, the mass of the planet Earth is given. Mass of the planet Earth is given. So here is just that I did not bring the what? I did not bring the information sheet where you would be given the mass of the planet Earth. But what we need to know is mass of planet Earth. Mass of planet Earth is equal to 5.972 times 10 to the power 24 kg. So this mass of planet Earth you'll be given. You always be given the mass of planet Earth. Once you are given the mass of planet Earth, that is the one that you come and substitute here. So for us to calculate the magnitude of the gravitational force that the Earth exerts on planet X, we are just going to say 5.2. 5.2 is given by F is equals to G M1 times M2 all over R squared, and we've said that this would fall to say G mass of Earth squared all over R squared. And the other thing that we need to know, is the capital letter G, which is the gravitational what? Constant. The gravitational constant. What is the value of the gravitational constant? That is what we also need to know. The value of the gravitational constant. So those two values you will always be given. So let me just give you the value of the gravitational constant. G is equal to 6.67 times 10 to the power of negative 11 Newton meter squared per kg squared. That is the value of the what? Of the gravitational constant. That is the value of the gravitational constant that we usually use. So that is the value that you'll be given, as well as the mass of the Earth that I've given you. That will be 5.972 times 10 to the power 24 kgs. Given that, all we now need to do is to come and substitute these two values into this equation. Come and substitute these two values into that equation. So you would come and say 6.67 times 10 power negative 11, and then times we said 5.972 times 10 to the power 24 squared, divided by, here we were given the distance in between the two centers. So that distance that was given, which is 4.2 times 10 to the power of what? 4.2 times 10 to the power 26 is the same distance that we are going to use here. So I'm just going to say 4.2 times 10 to the power 26 bracket squared, so that we can be able to calculate our force. So what is left is just us and our calculators, how we would be able to calculate that. So let's punch in our calculators. So that we can be able to find our answer. So we are saying that, let me just get to punch in my calculator, and then we'll get to compare the answers that you would have managed to get. So all we need is to have a working calculator. And make sure that your calculator is working properly. Just make sure that your calculator is working properly, so that you don't make calculation mistakes. So here the answer that I'm getting is 1.35 times 10 to the power of negative 14. So I'm getting my force being equal to 1.35 times 10 to the power negative 14. That is the force of gravitation. That is the gravitational force that the Earth exerts on planet X. So this would be given in newtons. So that is simply how you would have calculated your gravitational what? Your gravitational force of acceleration. Your gravitational force that the Earth exerts on planet X. That is what you were simply required to do there. And that is how we simply apply our Newton's gravitational law. Given that, they are now saying what is the magnitude of the force that the planet X exerts on planet Earth. So now this is where we apply Newton's what? This is where we apply Newton's third law. This is where we apply Newton's third law, which says that forces, they actually what? They actually exist in pairs, or else we get to say actions and reactions, they're equal but opposite, where we are saying planet A will exert a force of A on planet B, whilst planet B will also exert a force of B on planet A, which is equal but in opposite direction. So the force, gravitational force exerted by planet Earth on planet X is equal but in an opposite direction to the gravitational force exerted by planet X on planet Earth. Hence, therefore, this would be equal to what? Negative 1.35 times 10 to the power negative 40 newtons. The answer that we found, you just put a negative sign to represent its opposite direction, because it is now exerted towards what? Towards the planet Earth. So that is it, guys. That is to do with Newton's gravitational law, and that is what you would be examined on. So this marks our conclusion on what we have done. We have looked into Newton's three laws, which is Newton's first, second, and third laws. We have applied them, and we have actually delved deep into the experiment and investigation that seeks to determine the relationship between force and acceleration, which is governed by Newton's second law. And we have also taken time to do application of Newton's second law with regard to the definition of the net resultant force, and we have determined different variables in terms of when we have got scenarios of objects that are in interaction and we have got more than one or two forces acting upon. Thereafter, we went on to do Newton's universal gravitational law. Now we are now able to answer any question to do with Newton's laws. So let's meet in our next video, where now we are now going to dive deep and look into the electrostatic forces. So our next topic would be on electrostatic forces and electromagnetism. Once we are done with that, we are done with according to our ATP, we would be done with our term 1 topics for grade 11. So thank you so much. Let's meet in our next videos.